Alright guys, a lot of y'all missed today because there was some confusion with the codes. So what I'm doing, I'm going to go over what your work would have been in class on this video, and then we're going to go ahead and pick up tomorrow right where we left off today. It won't be any big deal. So what we're doing today is scientific notation. So our big thing is scientific notation, and it is a review, so we've had this before. So remember for scientific notation we have to have a decimal, and it has to be multiplied by a power of 10. All right, some power of 10. So our decimal is going to be somewhere. It has to be, our decimal has to be greater than or equal to 1, right? And it has to be less than 10, right? And then our power is just some power of 10, all right? 10 to whatever that power is, all right? So the first thing we're going to do, we're going to write numbers in scientific notation. The first one is going to be 8. We're going to do number 1, and we're going to write 8 in scientific notation. Right, so as a decimal, it has to be between 1 and 10, so it's going to be 8.0, right? And our power of 10, well, we want this to stay at 8. So in order to do that, we have to make this power of 10 equal to 1, and that would be 10 to the 0. Remember how the powers of 10 go, right? We have 10 to the 0 is equal to 1. 10 to the 1 is equal to 10. 10 squared is equal to the second power is equal to 100. 10 to the third power is equal to 1,000. 10 to the fourth power is equal to 10,000. And it just keeps going up. Every time we raise the power by 1, we multiply the number by 10. All right, so it's going to be equal to 10,000. All right. So just remember, again, if we raise the power up, we're multiplying by 10. If we move the power down 1, we're dividing by 10. All right, so let's take a look at the second one. The second one was number 2. It was 54. All right, so in order to get this 54 to be written correctly, I have to move this decimal point 1 space to the left. Right, if I move the decimal point right now, this would be 54 times 10 to the 0. Right, if I move the decimal point 1 space left, then I have to move this to the right 1, so that would be plus 1, so that would give me 5.4 times 10 to the first power. Any questions on that one? All right, just let me know. If you have questions, you can send me an email. All right, our third one, we have 0.02. Right, again, if you think about that, that's times 10 to the 0, right? But this is not in scientific notation because it's not between 1 and 10. So to get it there, I have to move the decimal point to the right. I move it to the right 1 to give me, actually I had to move to the right 2 spaces, right, to give me 2.0, right? And if I had to move that to this way, then I have to take my exponent and go 2 the other way, so I'm going to go that way 2, which gives me times 10 to the negative 2. All right. Number 4 is 229. 229 times 10 to the 0. Right. If I move that there, that gives me 2.29 times 10, and since I had to go back to the left, my decimal point, my exponent has to go up for each time I move. So it goes from 0 to 1, 2. So I get 2.29 times 10 to the second. All right. Number 5. All right, I have 187, and again we can always think of that as times 10 to the 0, right? So when I move that twice, that means this has to go plus 2 here. I get 1.89 times 10 to the second. All right. That should have been 1.87. I just didn't read it very well. This next one is 0.452, right? Again, if I make that times 10 to the 0, that kind of makes it easy to see, right? If I move this decimal point once to the right, that means that I am multiplying this by 10, so I have to divide this by 10. So I get 4.52 times 10, and dividing that by 10, I would get to negative 1. Remember, negative does not mean that you have a negative number. It signifies, that negative exponent just signifies that you have a fraction, a number less than 1. All right? Same thing here. I go 0.006009. All right, I'm going to make that times 10 to the 0. Then I move this 1, 2, 3 times, right? If that was 10 to the 0, right? That was 10 to the 0. I move this 3 times, so this has to come back this way. Since this went to the right, this has to come back. I multiplied this by 1,000, so I have to divide this by 1,000, so it's going to be 6.009 times 10 to the negative 3, right? Now the key here is that I'm multiplying here, I divide here. If I divide here, I multiply here. Very simple process. They have to balance each other out in order to stay the same number, right? Equal to the same value. The other thing is, I have these zeros here that have a place value because they have a 9 after them. If that 9 was a 0, I could just drop all those zeros, right? But I need them because they have place value. All right, let's look at 452. 452, again, if I write that as scientific notation, I can say times 10 to the 0. Then I have to move this, right, to get between 1 and 10. And since I divided this by 100, I have to multiply this by 100, which means it has to go up 2 exponents, so 1 and 2. So it becomes 4.52 times 10 to the second. The next one is 35,710, right? My decimal point is right there, and that's times 10 to the 0, right? So I move this back, 1, 2, 3, 4, right, to get 3.571. And notice, because this 0 no longer has a place value, I don't have to keep that 0. So I can put that times 10, and I move this 4 times to the left, which means I was dividing this number by 10,000. So now I have to multiply this number by 10,000, and with an exponent, that would be an exponent of 4, right? Because 10 to the 4th is equal to 10,000. Okay. The last example I'm going to do, and then I'll just go ahead and do them all. I was going to say the last one I was going to do, but I might as well do the whole page so you can see how to do it. 4 zeros, 5, 0, 2, 6. Again, if I say that's times 10 to the 0, right? Now I have to move 1, 2, 3, 4, 5 times. That gives me 5.026 times 10. And since I multiplied this by 100,000 by moving it 5 times, I have to move that exponent back. Move that exponent back the same number of spaces that I move this, right? So 0 minus 5 is going to be negative 5. All right, let me write that a little bit better. All right, so we get 5.026 times 10 to the negative 5. Okay, the next one is 787,000. Again, I'm just going to put the times 10 to 0 because that's times 1, right? That doesn't change anything. So now I need to move my decimal point back 1, 2, 3, 4, 5 times, right? So I moved it back 5 times. That gives me 7.87 when I do this, once I have a decimal point here, these zeros no longer have a place value, so I don't have to rewrite them. I put that times 10, and then because I move this back 1, 2, 3, 4, 5, then I also need to change my decimal to a 5 over here. My exponent, I mean, not my decimal, right? So 7.87 times 10 to the 5th, right, times 10 to the 5th is going to equal the same as 787,000. Right, my next number is 45.2. Right, again, I'm going to go times 10 to the 0. But again, this is not in scientific notation because I have a